Good morning to all. The topic which we are going to discuss is non-uniform bending, the theory and experimental part of it. So first of all, bending can be subdivided into uniform bending and non-uniform bending. In this, we are going to concentrate on non-uniform bending, where the cross section is not only bent but it also sheared in case of non-uniform. But in case of uniform, it is only the same radius of curvature, only bending is happened. The beam is depressed due to the load in case of non-uniform, but in case of uniform it is elevated. So first we'll see the non-uniform bending, depression of the middle point of a beam loaded at the middle theory. Let us consider a beam of length L supported on two knife edges A and B as shown in the figure. The load of weight W is suspended at the center C. It is found that the beam bends and the maximum displacement is at the point D where the load is given. Due to the load applied at the middle of the beam, the reaction W by 2 is acted vertically upwards at each knife edges. This bending is called non-uniform bending. The figure is shown. The beam may be considered as two cantilevers whose free end carries a load of W by 2 and fixed at the point D. Hence, we can say the elevation of A above D is the depression below A. That is, above A it is elevation and below D, below A it is depression. We know the depression of cantilever is WL cube divided by 3 into YIG. Substituting W as W by 2, we get WL cube divided by 48 YIG. Now we'll move on to experimental determination of Young's modulus by non-uniform bending. First, consider this image. Given a bar is fixed rigidly at a weight hanger which is suspended at the center. A pin is fixed vertically at the middle of the beam and the travelling microscope is focused on the pin. The microscope is adjusted such that the horizontal cross wire coincides with the tip of the pin. The initial reading of the microscope on the vertical scale is noted. Then load is applied continuously and the pin is adjusted and the value is taken, where loading and unloading is taken. So we can know the value of depression in case of loading, load increasing and load decreasing. By noticing the values of load increasing and load decreasing, that is W plus 50, W plus 100, W plus 150, 200 and 250, we can get the mean depression Y for a load of m gram. By substituting the values of mg L cube divided by BD cube value, we get Young's modulus of the beam by non-uniform bending. Thank you.